Bonjour and welcome to this third video of this GDL tutorial. In this video, we will start coding the 2D script. So for this video, we'll focus more on the geometry part. And in the next video, we'll talk more about coordinates. So for this one, let's go to the 2D script first. And then let's go into our plan view. And have a quick look at our table. You can see that this table is made of a specific shape and some specific line work. And it also has some attributes that will help display how the line work look or is visible. And if it has a field that allows it to be a solid object that can be displayed on top of a background, for example. So here, if you do not know where to begin with, you can go into the GDL reference guide and look for some specific 2D shapes. Here in the table of content, we can click on this chapter, and then we will see that we have some specific commands. In the GDL reference guide, here you have the specific command or method, and then you have how it is called. So here, if I want to draw a rectangle, which is the shape of our table, I will need to use the rect2 and 4 arguments, 2 coordinates of the bottom left corner and 2 arguments for the top right corner. So that's what we will do now. Here, I will call rect2 space and then 0, 0 for my bottom left coordinates and 1, 1 for my and 1 for my top right coordinates. I can check my script, which will tells me if my syntax is correct or is good, and then I can click here on the 2D preview. You can see now that I have a green square, which is normal because I have 1 meter and 1 meter as length and width. Then I can also check here directly in my 2D preview window pop-up. You can see I have my rectangle, and also, most importantly, I have this X here, which is the origin point of my object. Let's go back into our 2D script, and you can see that the rectangle here is green. I did not decide that it was green, it's just that the default color for an object would be this one. So if I want to have some control over this, then I simply need to create some attributes. Here I can go back into my reference guide and look for directives. Directives here exist for both 3D and 2D, but also some specific one for each script. Here we can see that one that will be very useful will be the pen method that will allow us to define a color for geometry according to the pen set of our project. We also have some other ones that are specific for 2D, which are here draw index, fill, and line type. Every time you see brackets in the description or the name of the command, that means that this information is optional. You can see it on arguments, or you can see it in the bracket names, in the command name, sorry. It will simply mean that you do not need to use it. So what we will do here is that we will define a pen, a fill, and also a line time as well. By convention, you can see here that I have written my statements in lowercase, but you do not need to do it if you prefer them to be uppercase. GDL is a case insensitive programming language, so it doesn't really matter here. But I prefer myself for them to be in lowercase. So now I need some arguments here for my 3 methods. I go into my parameter list. I can see here that I have here a pen type parameter and here a fill type parameter. What I want is a line type parameter which doesn't exist. So I will create a new parameter that I will call GS line type. I will follow the naming convention for the 2D representation here. GS naming Graphisoft. Here I will choose the line type like this, and I will also give it a proper name, and obviously a default value. The line type number 1 means that is the continuous line. Here I will go back to my 2D script, and now I will fill the void. GS cont pen, GS fill type, and GS line type. What I will do as well is put some tabulations so they are all aligned. It looks a bit better for me to do it that way. It doesn't really change anything when it comes to the compiling of my code, for example. So here you can see in the 2D preview pop-up that now my square is black. I can change this and test it. Here, if I go back into my GS pen content and put it in orange that way, or change the line type as dashed, for example, you can see now that my previewing window has updated accordingly. Similarly, if I go back to my 2D preview pop-up and change the scale, I can see the dashed line change as well. So now I will go back to the default value here, 1 and 7. So now that I have my directive here, I can save my script here after checking it, and then place my object. In my 2D view here next to this table, I will select my object 2 here, and here placed my rectangle. You can see it is properly placed. I can move it if I want to. However, I cannot resize it. If I try, it will simply move it accordingly. And this is no matter how I do it, even if I enter some specific value. The reason is simple. Here I have some constant value, so my object is not parametric. If I want it to be parametric, I need to link those values to some specific parameter. And those parameters will be the first 3 here. Those are very important parameters, which are A, B, and size X. A, B will be mostly used in 2D for a specific reason, is that here when I select an object, you can see here in sizes, you have a length and width, which is basically A and B. And here when you have the height, it's basically size X. So here if I want these two values to impact my geometry, then I need to use AB. So here in X, I will use A. In Y, I will use B. And now if I go into my parameter list and change A with 2, you can now see that my geometry has changed as well. Let's save. And then go back into our project. Now you can see that when I select my geometry, you can see that I can resize it dynamically or enter the value that I want. Here you can see that I also have some hotspots, which are the black dots here that we will talk about a bit later in this video. So here my object is quite nice, but it's not really good. If I put a slab below here, and here I zoom in, you can see here that my table looks to be above it, and that my rectangle here is see-through. And the reason is simple, is because the rect2 method is only line work. It does not have a fill, so I cannot represent it as some kind of solid object. So I need to change the method, and that's what we will do. Here we will go back to our 2D shapes, and instead of stopping at rect2, we will go at poly. We will simply draw a polygon. The reason is because the poly2 methods, there are several. You can see underscore, underscore A, underscore B, etc., etc. Take into account in the second argument if I draw a contour or if I draw the fill. So that's why we will use a poly2 command. But the version that we will use will be the poly2 underscore because each iteration simply add a new layer when it comes to how we can manage the fill. So here I prefer this second one because I have here a status code that I can play with when it comes to my nodes. So here I will copy paste this here. And then I will go back and paste that one. What I will do here before is comment out this line by simply writing an exclamation point before. That way my code will not interpret this line. Here I will put this in lowercase, and then we will go step by step in that command. The first argument is the number of nodes. The number of nodes is basically the number of corners of the geometry I want plus 1. The reason being that the first node needs to be written twice at the start and at the beginning, so my polygon is closed. So here I need 4 corners, so I will have 5 nodes. Then I have a number that will define my frame fill. That number will be 3. The reason being that I have a code that is 1 that tells me that I want to draw my contour, plus 2 here that tells me that I want to draw the fill. Basically, if I do not want to draw the contour, it will be by 0. If I do not want to draw the fill, it will be by 0, so the result will be 0. Because I want to draw both, then here it will be by 1, so this will be 1 plus 2 here equal 3. Then I will also have my coordinates. For the coordinates, I will go to a new line, so I can have each coordinates and its status for each line. It is a cleaner way to populate this code here. So what I will do here is that I will take the coordinate of all the corners in a counterclockwise way. This is simply my way of doing it. If you prefer clockwise, it's up to you. So usually I start by the bottom left corner. So here the first one will be 0, 0, and I want to draw the next edge. So it will be 1. If I do not want to draw that edge, it will be 0. So here next corner will be the bottom right one. Then top right. And then top left. And I finish with the first node, which I will give a -1 status code to define the end of the contour. Now let me check to see if it works. All good. So I can delete this part here. And if I click here to update the preview, nothing has changed. Our geometry still looks the same. But it only looks the same if we do not test it in the project. Because there are some stuff that needs to be tested directly in the project that we cannot see in the IDE. And here, when I go back to my project, now I have what we call a fill and my object looks solid. So here, now that I have some specific attributes, I can here go back into my preview. I do not need this here. And go into my 2D representation and change the fill type. For example, we will put it as a concrete block like this. You can see now that my fill changed accordingly. And if I change the color, everything here will be orange. So everything is working properly as intended. Here. The last thing that we will do in this video is talk about hotspots. You can see those 5 dots here, which are hotspots and serve as dynamic resizing. But not only, they also serve to place our object. For example, if I here use my object tool and place my object, you can see that it is placed by the bottom left corner. I can choose, for example, for it to be displayed in the middle, because that's where usually you place furniture. Those hotspots are placed by default at the bounding box of a specific shape. Because here my object is a rectangle, then it fits properly into our corner. But they are not really proper. If I add a circle instead of a square, then I will still have the 4 corners here, and this will be useless. So here, it's good that we are able to control this. In order to create hotspot, we need to use the hotspot2 command. This command takes a minimum of 2 arguments, which are simply the coordinates of the hotspot. So here I will put the coordinate for the 0, 0, which is the origin point here. You can see in the 2D preview pop-up that if we zoom here, we can see that we have now a new x that appeared. That new x simply indicates her hotspots. So now we will create 4 new ones and one in the middle that will be the default one. The default hotspot is the first one that is written in our script. So here if I want it to be the middle one, then I will need it to have different value than 0, 0. I will first copy this one 4 times. And then for the first one, it will be the middle. So alpha A and alpha B. And then I will use the same coordinates that I have here. So A0, AB, and 0B. I check my script, all good. I go back into my 2D preview window, and now you can see that I have 5 x's and 1 in the middle. Let me save. And then if I go back into my plan view, and then place an object again, you can now see that my object is placed by its middle. My origin point is still here at the bottom left corner. We haven't moved that origin point, but we have simply told Archicad that the default hotspot would be the middle one. So that is all for this video. In the next video, we'll talk about coordinates. See you on the next one.